Good afternoon, everybody. How's I/O so far? Oh, come on. Give me something. There we go. Awesome. Well, thank you so much for joining us. My name is Dave Smith. I'm a developer advocate on the IoT platform team here at Google.
I'm Renato Mangini, and I'm a developer programs engineer working on Android things here at Google.
And we're here to talk to you today a little bit about how you can easily get started developing for Android things using a tool you probably already know, which is Android Studio. So let's talk a little bit about Android Things for just a minute. Android Things is an extension of the Android platform to a brand new form factor, in this case for embedded and IoT. This is something that we've done in the past with other form factors such as Wear, Android TV, Android Auto. And Android Things is just yet another form factor where we're bringing all the power of the Android platform and the framework that you're already familiar with to this new form factor and building new use cases. This is a really great thing for embedded and IoT specifically because it brings Android's best-in-class tools to a space that traditionally hasn't had very well integrated tooling. You know, often development environments, debugging environments in embedded are decoupled, they're separated. There's not a real well integrated experience in a lot of cases. And that's what makes Android Things and Android Studio so awesome, is the fact that we have this fully integrated development experience where you can use these powerful tools like Android Studio to develop, debug, and deploy your applications to your devices for development and then again into production. Basically, it makes embedded development as simple as mobile development has become because of these powerful tools. So, most of you are probably, let me just see a show of hands. How many of you are Android developers in the room? How many of you use Android Studio roughly every day? Okay, great. So this is awesome because you guys already know this tool, right? And you know all of the amazing things that it can do for you in terms of development and deployment. But just to give you some background or some idea here, this means that now you can use some of these amazing Android Studio features that you're already familiar with, like Instant Run, the UI layout builders, and all of these great tools to now build applications for embedded devices. This also means that you can leverage all of the deep integrations that are already in Android Studio for Google services, the deep integrations for things like Firebase, as well as the Google Cloud Platform. And in addition to these features, Android Studio also has these fully featured debugging and profiling tools, right? You have this amazing step-through debugger that you can set watch points, execute arbitrary code expressions. You can do all of these things on your target device the same way you do when you do your Android development in apps today. But in addition, we also have all of these new profiling tools. You saw some of them were just announced at the developer keynote yesterday for profiling CPU performance, memory, object allocations, and tracking down issues in your program and performance problems. So all of these tools that we've announced here at I/O, as well as the ones you're already familiar with using in Android Studio, you can now apply those same tools to developing for embedded and for IoT. All right. So that's enough about talking about what you probably already know. Let's talk about the new stuff. So as you probably heard yesterday, we announced the new preview of Android Studio 3.0. And one of the new features in Android Studio 3.0 is direct support for Android Things as a device form factor. So let's take a look at what we've added. So now if you are using the preview of Android Studio and you create a new project, what you'll see is Android Things is now listed as one of those form factors that you can select when you build a new project. Now the interesting thing to note here is that it's not mutually exclusive with phone and tablet or any of the others. So in theory, you could build an application that targets both phone and tablet and Android Things. Interesting use case for this might be maybe you want to build a companion application that goes along with what's running on Android Things, and you'd like to share as much code as possible. You could actually build them into the same application project, just using different entry points via different activities. And we'll talk about that a little bit more in a bit. All right, so what does that actually do? When I check that little Android Things box, what is being added to my project? So what that does is it walks through, and when it creates the new project, it automatically adds the Android Things support libraries to that project for you in the form of the Gradle dependency as well as the required manifest element there. If you've been through our documentation, you've seen us telling you to manually add these things if you've been playing around with the preview before, and now Android Studio is going to add them for you automatically. So if you're not familiar with Android Things development directly, this support library essentially adds a bunch of new APIs that are specific to Android things for interacting with low-level peripheral devices. And these APIs have names like GPIO, PWM, SPI, and all the other ones that we have listed there. And maybe you've heard of those things, maybe you haven't. But essentially, they're all interfaces that are used to connect low-level hardware like buttons, LEDs, sensors, and things like that. So now you can communicate with those directly inside of your app, and the support library allows you to do that. And now Android Studio will automatically add that to your project if you target Android things. The next thing that you'll see when you create a new project targeting Android things is an activity dialog to add a new empty activity to your project. Now, this is also important because an Android things application must have at least one main entry point activity. So to discuss that a little bit, let me kind of walk you through what happens when Android things starts up for the first time. So Android things is a little bit different than traditional Android in that there's not a launcher application on the device that the user would choose to pick a particular app and then launch that so that they can interact with it. It's not to say that Android things doesn't have a graphical display, because it might. But what it does mean is that we have to somehow provide a mechanism so that Android can automatically launch whatever the primary application is that you've developed once this system fully boots. So the way that we do that is once Android is finished booting, there's an intermediary app that we've built into the system called the IoT launcher. And that launcher is looking for a very specific activity of intent on the system that it can launch as the first main application that's ready to run whatever code you've developed. Okay? Now, again, if you've done some Android things development before, you might have seen this in our documentation. But essentially, it means that you are creating an activity that has an intent filter that includes this IoT launcher category. And the IoT launcher app will look for an activity that has that filter and automatically launch it as the primary application on the device. Now, from that point, you can do whatever you'd like. You could start other services. You could even launch other applications if you have multiple APKs. But that's sort of that single entry point that we require to get your app up and running. And again, when you use the new activity template in Android Studio, what it's going to do is automatically add all of that boilerplate to the manifest for you so that you don't have to remember to do that for that specific activity. All right, so one more thing about Android Studio. I mentioned before that there is a possibility for having a display on an Android Things device, but it's not required. We say that effectively displays are optional in Android Things. Because of that, there are some Android behaviors that work a little bit different than in traditional Android. And one of those that's very common are APIs that would typically show a dialog to the user. One example is Runtime Permissions, probably the most common. Now, the issue with showing a Runtime Permissions dialog to require access to particular APIs is we can't necessarily do that if there's no display. So in Android Things, these dialogs do not display, and permissions are granted to applications by default, even if they're dangerous permissions. We say that they're granted at install time, but it turns out there's a little bit of an implementation difference in here that some of you may have experienced if you've done the development so far. It turns out that those permissions are granted when the device first boots. So on reboot, the device will grant application permissions based on what they've requested in their manifest. So there's no dialogue, but during development, this creates a bit of a gap. There's actually a period of time between when you install your app on the device the first time and when it may or may not have been rebooted where that permission is not granted to you, and that can cause some friction when you're doing development. There are ways around this by manually rebooting the device, or in some cases, you can manually install the APK using the grant permissions flag to override all of this. In Android Studio 3.0 preview, this is now done for you. When we detect that you are connecting to an Android Things target device and you download your code out of Android Studio, we will automatically grant those permissions at install time the way you expect so that you don't have to do these manual workarounds or reboot the device. So all this is now much smoother, much easier to work with now that we've got full integration with Android Studio. OK, so now I'd like to show you some of this stuff in practice. So I'm going to hand it over to Renato, who's going to show you a demo. Can we switch to the demo, please?
Hi, everyone. Are you ready for a live coding demo? Hold your claps for later. Let's check if everything works as expected. I just launched the Android Studio 3.0, which we just launched. We just announced yesterday. You can download it right now. It's public. But it's on Canary channel yet, so it's not stable. That means this is risky. What I'm going to do here, I'm going to start a new project, a new Android things project from scratch using the support that we just added to Android Studio. And then from there, we're going to do something else. I will enable form factor support for Android things. I'll add an empty activity, just like Dave showed. And I don't want to deal with UI now, because I will actually run this app on this device, as you can see here. And this device has no UI, no traditional UI. So let's disable that. OK, now it's generating a project. I explained a little bit of what this device is. This is one of the many boards that we support Android things on. And on top of that, you can see what we call a hat, which is just a board with a bunch of sensors and buttons and segment displays, etc. We're going to play with that a little bit. OK, here we have the activity. If I switch to my build Gradle, you can see that the Android things support library is added automatically. So I'm ready to do something. What do you want me to do, Dave?
Well, I guess the first project everybody does with hardware is a blinky light. That's kind of the hello world of hardware. So let's do that.
Hello world, right?
Yep.
OK, let's do a hello world here. First thing, we have this notion of a driver on Android things. We don't want you guys to do all the low-level stuff for every standard peripheral, every standard sensor or display. So we provided, and we count on the community to provide more of those high-level drivers for the sensors. So you don't have to deal with I2S, I2C, SPI, and those low-level protocols every time you just want to blink a LED. For this particular hat, for this particular board with a lot of sensors, we created a meta driver that contains every single sensor or peripheral that has in that board. So I will start by adding the dependency on that driver. Oh. Is it better? Yeah. Okay. OK, so I just added dependency. This library is published on JSandar. So it means that when I sync, it will add all the transitive dependencies. And why it does that, I will go back to my activity. OK, now I'll start with open the LED. See, there are 3 LEDs here. They are currently on. There is a red, green, and blue. And by using this class from the driver, I can open any of these. I will open the red now. There is an exception. I'll just handle it the default way. And set the value. I will set the LED direction as out. So this is something that we send a signal to, not something that we collect a signal from. And I will do that in a loop. I'm pretty sure Dave has something to complain about that. We'll talk about that later. OK, if you're an Android developer, you can see that what we are doing here. We opened the LED. We got into a loop. And we set the value every 300 milliseconds to an alternate value. And now I will run the app. Here are the devices I have. The only device I have connected is the IMX7D, which is this board. Cross your fingers, please. If all goes well, after some time, the red LED will start blinking. working. Awesome, right? I'm done.
So it works. That's great.
Yeah.
But you're a pretty experienced Android developer. I'm not real sure that putting an infinite while loop in onCreate is the best way to handle this. Do you think maybe we can fix that?
Yeah, I told you guys. Yeah, I knew he would complain about that. OK, so that's a very good point. Despite not having a UI, Android things should not do, you have to follow the same rules of Android. You should not block the main thread. Why? If you don't have a Y, you don't need to refresh the UI, right? However, you have events, like keyboard events, that can still be sent to your application, to your main thread. You have sensor events. So you have a bunch of other stuff that, so you should not block the main thread. That's a main rule for Android, and that is something we are doing here. So let's fix that. The way I'm going to fix this, there are multiple ways to do it. You guys probably know you can create a service, you can create a thread. I would do it the simplest way here. I just create a handler, attach that handler to the main thread, and add each set value to the end of the looper, of the main thread looper. It's going to look less complicated than it sounds.
So as Renato mentioned, one of the things that we're doing is we're ensuring that the main thread in Android continues to remain free so that system events can still come into your application, whether those are lifecycle events or he mentioned input events. This also means that in general, if you have to do any regular polling of an input or something along those lines, you want to make sure that you don't do that on the main thread either. So in this case, we're scheduling an output, so the way that we're doing this is fine. But if we need to poll a sensor or read some value from another input on a regular basis, we might actually want to use a background thread to do that. Now, it could be a handler thread. That seems to be the simplest way to sort of modify what's being done in this case. Or you could use async task or other things that suit your development workflow because it's just Android. They all work the same way you expect. But it's important to realize that when you're working with some of this hardware, it's still good to offload those regular repeated long-running operations off the main thread, even though it's not a network access or something that you might otherwise traditionally consider as one of those blocking operations. OK,
good job.
Yep. Sorry.
And now we have the code that supposedly should work. Again, let's cross the fingers again. Actually, first let me just go over it pretty quickly. I have the handler. The difference between now and before is that now I have a handler, and the handler like sliced all the work that the looper was doing, the while loop was doing, into this method, run and reschedule. It does exactly the same. However, at the end, it posts itself at the end of the looper. So it can do whatever it has to do, like a reading sensor or reading keys, processing any event that's coming to the main thread, and then it does another step, and then it reschedules again. Again, this is not specific for Android things. This is Android. And you won't know if it's working or not, so because it was blinking before. I would change the LED to the green one, so you don't have to trust me. Done.
There you go.
Awesome.
All right. That's good.
It's OK now, right?
It's good-looking code. I think we're following a good pattern here.
OK, bye-bye.
Well, I mean, we work for Google. I feel like we should be able to do a little bit better than just blink a light on stage. You said something about sensors and displays on this board. Can we get something a little more interesting going? OK,
we can do that. We can do that. So as I mentioned, there is one sensor, one main sensor in this board, which is this tiny thing here. Can you see right here? It is the BMP280. It's a temperature and ambient pressure sensor. And we can easily connect to that using the Rainbow Hat driver. So let's do it. And what I'm going to do is not only read from the sensor, I will also show the results, like the temperature, on this segment display here, right?
I think that's a better demo.
See? And how am I going to do that? That's really easy.
So what you may have noticed already is earlier in the presentation, I talked about interacting with a lot of these things using low-level buses like GPIO, I2C, et cetera. And none of that is actually in this code. The reason for that is that the driver that we've written for this specific peripheral, the Rainbow Hat, abstracts all of that away. So there's two reasons that we're showing you this. First of all, that using these drivers is a much faster way of getting started without necessarily having to deal with all those low-level details. But these drivers are also open source on GitHub, and we'll mention a link to that a little bit later on. So you can also use them as a reference to see how to build something with these abstractions using those interfaces directly, and you can read that code. Are you done yet?
Yeah, of course.
Oh, okay.
You take too long talking. So on the onCreate, I initiate the driver, and I initiate the display with a few default values. And here in the loop, I will keep the LED so you see that it's processing. And I will display on the display the sensor value, read temperature. And that's it. Done. If you're wondering, this is in Celsius, OK? You have to do some conversion.
All right, very good. I concede. Can we switch back to the slides real quick? There we go. Awesome. So you've just seen how easy it is to get started very quickly using the new Android Studio to create a new project, add some code to it, and communicate with peripherals. And you've seen how easy that is to do in Java. But again, if you were at the keynote yesterday, you heard that Kotlin is now a first-class citizen in Android Studio as part of the new preview. So can we use Kotlin to develop for Android things? Well, I don't see why not. So this is not from the demo, but just a simple example of Java I've thrown up here to give you an idea of what some of this code might look like if you're interacting with other peripherals on the hat. This is actually communicating with that rainbow LED strip that was on the top there, as well as interacting with the button. And it's just doing some basic setup to change the color based on a button in Java. This code snippet is fairly straightforward. It's about 25 lines of code. But what if we were to take that sample and write it in Kotlin instead? The same code looks a little bit like this. We've dropped out almost, well, actually a little more than 10 lines of code. And you can see some of the things that are gone. The try-catch blocks are no longer there anymore. The callback is much cleaner using a Lambda. And even the array initializers are also much more expressive and easy to read. So this code is a lot more concise and a lot more of a joy to even write. So what do you think, Renato? Can we show them Kotlin running on the Android Things board?
It's getting too complicated. Yeah, sure. Why not?
All right, let's switch back to the demo and see if you can do it.
So again, this was just launched. I'm just preparing you guys if something goes wrong. What we're going to do here is we're going to start a new project. You can the Kotlin support on Android Studio. You can add Kotlin and Java at the same time in the same project. Just to simplify things, and you guys know that I'm not cheating here, I will start a new project. Okay? And I will add Kotlin support, obviously. Again, let's not do a phone and tablet. Let's do an Android things. Same empty activity, same no UI layout.
So one of the things you can see if you haven't seen this demo yet is that when you include Kotlin support, by default, the main activity is created in Kotlin. There's a little bit of a Java conversion that happens there, but we're automatically in Kotlin already.
Yeah, this is the main activity. and it's in Kotlin, and it does nothing. So now it's my job to do something with that. First, I will add the dependency on, if you guys remember well. The same dependency. See, our driver is written in Java. It's there. It's open source. You can look. It's Java. It's published as a Java library. It's published as a Java AR. And the fact that in Kotlin you can just add the dependency and use it like for free. There's no extra steps to use that. That's really amazing. You know what? Just remember something. I'm not a Kotlin developer.
Is there something in the IDE maybe we could use to help you around?
Yeah, and in fact, luckily I kept this class here. I'll just add a little bit of more correctness to it. And I will copy my class, Control-C, Alt-Tab, select everything here on the Kotlin side. This is the Kotlin file, OK? And I will Control-V. And boom. Here it is.
Automatically converted into Kotlin. See, you are a Kotlin developer. You just didn't know it.
I just became a Kotlin developer. Yes, see, my code is great. Have a lot of exclamation points.
That's awesome.
So you don't trust me, right? Of course you don't. I wouldn't trust myself. Let's confirm that it's working. Currently, I have the blue LED here, right? So let me change that to the, what color do you want? Red? OK, let's do red. Shows better on the TV. See, I'm running the Kotlin app. I'm not running the Java app. Launching. Boom.
There we go.
Awesome.
Nicely done, sir. Nicely done. All right, let's switch back to the sides, please. OK. So we've given you just a very quick tour today of the new features in Android Studio that are specific to Android things, as well as just a very simple walkthrough of how you can get started and how quick and easy it is to really just get up and running from zero to a working project using all the tools that are available here. A couple things while you're here at the conference that I think you should check out. First of all, we're going to be in office hours immediately after this, so if we don't have an opportunity to answer your questions during Q&A, you can always follow us over there and we'll continue the discussion. Also, we have a bunch of Android things code labs in the code lab section. We have 4 of them, ranging from some basic peripheral stuff like this to using TensorFlow. So check those out, and you can play around with Android things in the code lab area as well. Once you get home and you want to start doing some of this development for yourself, check out the Android Things documentation, which is on the Android dev site at developerandroid.com/things. Download the new Android Studio Canary at Studio Preview. And we also like to encourage you, if you're working with Android things, to join the IoT developers community that we have on G+. Us and other folks from the IoT team are constantly on there, answering questions and helping folks out and watching you share your cool projects and other things that you're doing with the community. So please check that out as you will as well. Looks like we've got some time for questions. So if you do have questions, please feel free to come up to the mics. Otherwise, thank you very much for your time today.